Good morning, ladies and gentlemen. We're delighted to have you all for this unique symposium of Water at Dawn, a journey from thirst to thought. Before introducing the laureate of sustainable development, we would like to introduce the Tang Prize.
The Tang Prize was established by Dr. Ying Liang in 2012. He firmly believes that remarkable advancements stem from brilliant education. It recognizes extraordinary achievements in four major fields, which are sustainable development, sinology, rule of law, and biopharmaceutical science.
The Tang Prize Foundation has been inviting many of its laureates to Taiwan to confer research and experiences with both scholars and students, which is why we have the privilege to organize this symposium for you.
Before we start, allow us to introduce our distinguished guest. First and foremost, let's give a big applause to our principal, Guo Zhenxiang. Now, we would like to welcome the director of the Department of Planning and Developing the Tang Prize Foundation, Hu Ying. Last and also the main reason that brings all of us here together is Dr. Omar Yaghi, the 2024 Tang Prize laureate in Sustainable Development.
Dr. Omar Yaghi is a person who is filled with persistence, overcoming all the difficulties while also possessing a humble mind in this world-leading research about harvesting water from desert air. The materials have already been extensively designed for carbon collection, the storage of hydrogen and methane, and water harvesting applications in arid areas.
And now, we will watch a short video to learn more about the achievements and greatness of Dr. Omar Yaghi.
This young boy, beaming with joy, is Omar Yaghi, growing up in Amman, Jordan.
He was tasked with collecting water whenever he could.
At the age of 10, he discovered a book by chance in a library and encountered the beauty of molecules. He was totally captivated.
I felt like I am being drawn by those molecules, right? It's almost as if I met another person and I fell in love. I was drawn by them, and they entered my heart.
This experience plunged Yaghi into the magical field of molecules.
He shattered tradition and embracing innovation using a Lego-like approach combining metal ions with organic linkers.
And pioneered reticular chemistry. The metal organic frameworks, MOFs, he created are incredible. They are highly porous, tiny like a sugar cube, that somehow encompasses an entire football field. They are remarkably absorbent. Studies confirm, without any external force, they can harvest water even from desert air, which holds profound meaning for him.
For me, it was powerful. That meant that everyone in the world potentially can have their own device.
MOFs could be designed in countless ways, offering infinite possibilities. Besides water, other substances can be captured as well, such as carbon dioxide and methane. Now, Professor Yaghi embraces AI technology, seeking to accelerate the fight against global warming.
He moves chemistry, climate, and sustainability and the world forward with his science.
Beyond numerous hours in the lab, Yaghi finds joy in gardening. His backyard is a haven of carefully cultivated plants, once rooted in the desert, now blossoming in full glory. Yaghi's dedication to nurturing his passions offers a beacon of hope for a sustainable future for all humanity.
Following the video, let's welcome Principal Guo Zhenxiang to give us her welcome speech.
distinguished guests, esteemed educators, and honored students, good morning. On behalf of National Hsinchu Senior High School, it is my privilege to welcome to this esteemed symposium. First, I would like to extend a special welcome to Professor Omar Yaghi, whose pioneering research in harvesting water from desert air has not only garnered prestigious accolades, but has also inspired generations of scientists and thinkers. His work exemplifies the spirit of innovation and perseverance that we strive to instill in our students, reminding us that scientific exploration continuously broadens the horizons of possibility for humanity's future. Therefore, we eagerly anticipate today's speech. We are also deeply honored by the presence of Ms. Hu Ying, Director of the Tang Prize Foundation, and other esteemed leaders in education. Your participation underscores the critical importance of institutional collaboration in cultivating the next generation of citizens, innovators, and global leaders. Thank you for being part of this important event. I think we all look forward to the ideas, discussions, and connections that will arise from today's gathering. Hopefully, we can continue to advance knowledge, inquiry, and the pursuit of a better future together. Let us make this symposium a truly memorable and meaningful experience for all. Thank you.
Thank you, Principal Guo Zhenxiang, for your words. Next, let's invite Dr. Omar Yaghi to deliver his speech.
Thank you very much. Thanks, everybody. I'm delighted to be here. And this happens to be the first time that I speak at a high school. I speak at many universities and many places around the world in conferences all the time, but I've never been to a high school, so this is quite a privilege for me. Thank you for inviting me. So today, what I'd like to do is, first, I want to explain my title, Water at Dawn. It was my job growing up to be the one waiting for the water to come in from the city. The water came into our house from the city only once every 2 weeks for just a few hours. So you had to be ready when it came to allow the water, turn the faucet on so that we can fill the reservoirs with water for those few hours. And it was that water that we would use for the next 2 weeks. And so thus, I was waiting for the water at dawn at that time. But that's not as important as what comes after that, is that today I'm going to tell you about my journey from living in an arid environment where there is not much water, and water is precious. Every drop is precious, to how we went from what is important today, which is to provide the water, to drink water, but also to develop from that a whole field of science that enriches the mind. Thus, my title, A Journey from Thirst to Thought. Thought is very important because it is for the future. It's for the future generation, that you can deploy our inventions for the betterment of humanity. So very quickly, I want to just share with you where I come from. This is Jordan. I come from Jordan. It's in the Middle East. It's surrounded by Syria, Israel, Iraq, Saudi Arabia. And it's a small country. It's a country of about 10 million people. I grew up in an environment not too different from this. This was around our house, okay? And this was our house. You can see in the background of a humble house. This is me standing there with a book, okay? I couldn't separate from my books when I was growing up. And you can see here a pile of rocks. When I was not reading or writing, I was always supposed to be doing something. You were never idle. You have to be doing something. And so here there is a garden, and from that garden there are many rocks, and we needed to move the rocks constantly over to this pile. In the background, there are cows that we raised, okay, and sold. And I lived with the cows, actually, okay, in a room. Half of the room was where the cows are, and the other half was where we dwelled, where we slept and ate. And so when I used to go to school sometimes like this, I smelled like a cow. Okay, so, but throughout my story today, you will see that great things come from almost unremarkable beginnings. Okay, and the plus thing about this is that my father had a shop. It was in the middle of Amman, the capital of Jordan. And here was my school. My father spent every penny he made to send us to a private school, okay? And this is our home here. So I would wake up at 5 o'clock in the morning and start the journey walking to the shop with my father, okay, and have sometimes breakfast. He would cook breakfast for us in the shop. And then after breakfast, you walk over to the school. And when school was over at 2 o'clock, you walk down. And again, my father would have these lovely sandwiches, okay, like almost like hamburgers, but flatter, very delicious. And I would have the sandwiches that my father prepared. This stop at my father's shop was absolutely essential in making me appreciate the quality and hard work. I was taught, I would help my father with the chores in the shop, cleaning the tables, cleaning the windows, making sure the shop looks very shiny, very appealing to the customer. So he taught me that if you want to do a job, you have to do it well. Otherwise, don't do it at all. That's what I was taught day after day after day. You have to do the job well, and you have to do it completely. Otherwise, don't do it. So I learned the work ethic through this journey as I stopped to help my father in the shop. And towards the end of the day, I would walk home, and for the rest of the day, I would be spending time writing and reading my homework. I didn't play with the other kids. I was a weird kid. I sat there in a corner on the floor with a little table. I was writing and reading, and when I'm not doing that, I'm just staring at everybody, watching what everybody was doing, and not participating. I didn't play soccer. I didn't have any interest in bicycles or anything like that. I didn't have any interest in games with the other kids, with my brothers. I have many brothers and sisters. And so this is a fact. And my obligation as a teacher is to tell you the facts. You can use them as you like. You can develop your own wisdom from facts. So my moral obligation is to communicate with you the facts. And that was a fact. I'm not ashamed of it. I'd like to be alone, and I don't like my parents to tell me what to do. So in 3rd grade, I told my parents, don't talk to me. Okay, don't tell me what to do. Don't ask me for my grades, because I felt I have an obligation to do well, and I was doing okay in school. So I didn't feel obligated to talk to my parents. I had a lot of love from my parents. So our house didn't have modern conveniences. We didn't have running water. We didn't have light, electric lights, okay? So it was very primitive. But we had a lot of love from the parents. The parents really cared about us, about what we did as much as they could. But every one of you, every one has a break in life. You get a break, okay? Like they say in Hollywood, actors, I got a break, or actresses, I got a break. I got a role in a big movie, that's the break. I had my break, and the break was that I entered the library when the library was supposed to be locked at noon during lunch hour, but it was unlocked. And so I went in there, and I picked a random book, and there I met these. I didn't know what they were. I was completely captivated by them. They did something to me that I never felt before, okay? And so that, I didn't know what they are. Later, I learned they are molecules, okay? They are the building blocks of life. And when I went home that day, I didn't tell. I was very close to my sister. I didn't tell my sister, I didn't tell my brothers about what I felt, what I had, because I almost felt like, oh, I met a very lovely girl that I'm in love with. It was the molecule, okay? Okay, that. So my interest in molecules, I started wanting to learn more and more about these figures. And the more I learned, the more I realized, my God, they are the makeup of life. Okay, they are truly inspiring. How do they exist in our body? How do they exist in nature? How do they exist in the things that we use every day? Why do things appear the way they do? It's because of the molecules that these things are made of, that we are made of. So I can see that there is a huge excitement awaiting me as I learn more and more about these molecules. But one day, as I was coming down to my father's shop from school, he said, "You're going to America." And that was in my 9th grade, okay? In 9th grade, basically, I won't tell you the story, but basically, I took my parents' or my family's savings, $9,000, and got a visa to go to America. I was shipped off, deposited in a plane like this one, a KLM flight that's stopped in Amsterdam and continued on to New York. I was shipped at 15 years old to the United States, okay? And my elder brother had arranged a house for me to live in with a couple that their kids graduated and they had an extra room. So I lived with this American couple. I paid them $500 a month. And of course, the $9,000 didn't last very long. So when I arrived in America, I picked up the phone and I called home. I said, "What do I do now?" They said, "Oh, well, take your grades from 9th grade and show it to the nearest, go to the nearest college and ask them to take classes." And of course, I thought, what a ridiculous suggestion. But I did. I went and I went to Hudson Valley Community College. Okay, it's a 2-year college. And I went in, and I had my English was not so good, so I had prepared a statement. So I went into the president's office, the admissions office, and I read the statement. And the guy said, wait, like, what is this? I said, "I just want to take class." So the deal was that I take classes, calculus, chemistry, biology, and English. And if I did well that semester, I would be admitted into college without going to high school. And I did. I did. That was the American system. Allows everybody to go in. And when you go in, as you work harder, you move up. So I went to Hudson Valley Community College, and yeah, if you do well. But in the meantime, I was trying to explore, what is this America about? And we didn't have McDonald's at the time in Jordan, okay, where I grew up. So the very first thing I wanted to do is go into a McDonald's. Well, McDonald's has a menu of things, fries, hamburger. So I am with my dictionary looking for fries, and there is no fries in my dictionary. So I didn't know what the hell is going on. And so I basically pointed to some items, and out came a mountain of food. I had ordered a lot more than one person could eat. And then the lady behind the counter asked me, do you want this for here or to go? I couldn't understand. You want it for here or to go? It wasn't clear. Why would I go somewhere? This is a restaurant. I should sit down and eat my food. For here or to go? When you think about it, it's a very complicated expression. Do you want it for here or to go? Well, yes, I want it now here. And I don't want to go, right? Because I want it. So you have to overcome these difficulties. The American people were very kind to me, very patient. And so I would ask, and I was not ashamed to ask for guidance, and I got guidance. And then I transferred, after I did well in the community college, I transferred to a 4-year college. And this is what I found, that all the undergraduates are partying. I was absolutely horrified. Like, this is college. You're supposed to be studying, and they are partying. Every day, partying. Okay, and I'm in the library working, of course. I didn't participate in this. But in college, I immediately went into the lab, okay? And it was an organic chemistry lab. And in organic chemistry lab, the very first thing you learn is how to crystallize organic compounds. And what you do, you dissolve the compound, and then you add a solvent that the compound is insoluble in, and out comes the solid. And the solid, when it falls, it looks like snow. I saw that, and I thought, I am absolutely in love with this. I love crystals. The reason I say this is that your interest in a topic does not have to be deep. It doesn't have to be intellectually deep. It could be just because you love the beautiful crystals. That was very important to me. I didn't have to know what they are made of. I didn't have to know so much chemistry. I just knew I love them. So that deepens my interest in chemistry and molecules. And then I finished undergraduate, and I wanted to go to graduate school to get my PhD in chemistry. How did I choose my university? I chose it because there is a professor there working on beautiful compounds. The compound looked like this. It looks like a soccer ball. Well, I looked at it, and again, the beauty of molecules was attractive. No real intellectual depth. I didn't have to know everything about it. I just knew I want to work with this thing. So I went to see him. He admitted me to his group. I was studying for my PhD, and there I was taught that science begins with doubt and questions. Whenever you make an observation, you don't accept it. You ask, is this really correct? Is this observation reproducible? So you begin with doubt and questions. Okay, but in graduate school, I had a project which was the simplest thing you could ever think about, taking a proton out of a molecule. Okay, deprotonation reaction, the absolute simplest reaction. So that was my job, is to use that molecule like this and take one proton out. And it took me a whole year to arrive at a stage where I think I did the reaction right. And I knew it's going to be orange solution. But then by the time I took this solution to analyze it in another building in my school, it had turned into a brown, disgusting gunk. Okay? So my hard work was falling apart right in front of me. I was spent a whole year of my life. I had traveled thousands of miles to go to America, okay? And I was failing. So I went back to the lab, and I was very depressed. It was late at night, and there was a postdoc, a more senior researcher there, and I said, what do I do with this? And he said, "Oh, Omar, throw it away. It's disgusting," basically. And I said, why would I throw away a product that I have obtained over a whole year of hard work? And so what I did that night is I didn't throw it away. I worked it up, let's say. In chemistry, it means I collected the solid, dissolved it, and tried to make a crystallization. And what I made was that. It took me 6 months to figure it out, but that's what I made. I made a compound that looks like a rice ball. And it loves to seek out special molecules and trap them into its pores. There was nothing like it. Nobody has ever made anything like it. And nobody has ever been able to make anything like it since. So here's a discovery. This is the point I want to make to all of you. No matter where you are in your, whether you come from humble beginnings or not, whether you come from a big family, small family, whatever your background is, a scientific discovery propels you from where you are to the heavens. No other discipline does that. One discovery that is made over a short period of your life could propel you to be the top of your field. No one, except little me, at the age of 2021, I made this discovery. And so I used, and published this work, and it was recognized. And I said, I want to go to Harvard, okay? It's the top university in the world at the time. And so I went there, and I did what is called postdoctoral fellowship. After your PhD, you do 2 years or 3 years of training, because I was beginning to be interested in academic research. And there, my professor taught me research is an exercise in optimism, okay? My PhD advisor taught me research begins with doubting questions, a pessimistic view. My postdoctoral advisor taught me research is an exercise in optimism. That means if you're optimistic, good things will happen. And in your life, you will be exposed to conflicting messages, seemingly conflicting messages. Somebody saying one thing that seems true, another person that you respect is saying something different that seems opposite. My thinking was, the way I've dealt with that, is that I will consider these points in my thinking. And in so doing, I didn't have to follow one or another. By considering them, I developed my own thinking about science, my philosophy about science. And my philosophy about science is that science discoveries come to those who do the experiment, okay? Those who are not afraid to do the experiment will do the experiment and have more likelihood to discover something great. And that has been true throughout my career, which has spanned now, I have been in research for over 40 years. And that has been true for every single discovery, is that we wanted to do something special. And the only way we could make great discoveries is by doing the experiment, not by talking about doing the experiment, okay? So that's how my interest evolved in chemistry, and I wanted to be a professor. I got a job in academia. First, I didn't know whether I want to be a professor in a university or be working with industry as a chemist. Industry gave me a very nice salary, $85,000 in 1991, $85,000 a year. Academia, I interviewed at these places. I interviewed at UC Berkeley, they didn't want me. Columbia didn't want me. These 3 schools wanted me, and I love Arizona because it's desert, and they had a new building, and I thought, oh, well, And it looks like fun. Okay, so I went to Arizona State, and there was the beginning of what we invented and what was referred to in the introduction. My salary at Arizona State was only $38,000. So now we come to another major milestones in one's life, and you will face this, okay? Money will come to you if you have passion for what you're doing. Yes, I turned down a job for $85,000 for a $38,000. Why? Because I love research. And I didn't want somebody to tell me what to do. In industry, somebody will be telling you what to do. And sometimes you might discover something, and the manager will say, no, that's not going to be profitable. So it's not about discovery, it's not about advancing knowledge, it's about making money. So I was not as attracted to that. I wanted to have freedom. Ironically, even though I wanted freedom from everything, parents, people, teachers, whatever, I dedicated my life to building traps for molecules, okay? To trap the molecules inside these containers, these molecular containers. And that's how things have evolved. The very first discovery was made by a student in my lab at Arizona State who could barely speak English. And no other professor in the university would take her because she didn't speak English. And in fact, 20 years later, I learned that she was selling flowers on the street because she needed money. But she, again, a story of humble beginnings for her, she made the very first discovery of MOF in my lab. And we published this result in Nature, in the highest impact journal of science, okay? And again, she didn't speak English, she was very humble, came from mainland China, and together we worked. And she made the very first MOF, okay? So what I learned early on in my research is that an idea is worthless unless it can be brought to fruition. You can sit there and talk about an experiment, talk about a great idea. It's nothing until you do something about it. You do the experiment, you build what you're thinking, or to bring it into reality. So this was the molecule. This was, okay, I won't describe it, but it traps these pyridine molecules. That was the beginning of MOFs. Well, I did so well in graduate school, by the way, and I'm now going back a little bit because it's very important in the history of MOF. When I was a student, PhD student, my professor sent me to China in 1989 because as a visiting scholar, and there I met Halian Li. And when I became professor in '92 at Arizona State, Halian wrote me and said, oh, I see that you are working on MOFs and doing very well, but I can do a better job. I said, okay, you can come and show me. So he came and joined my group. Okay, see, I can do it better than you. And there he discovered the most magnificent MOF. Okay, and these are crystals of what we call MOF5. MOF5 had the highest surface area ever recorded in the history of humanity. Okay, let me show you. This is what the structure looked like. The yellow ball indicates the porosity of the structure. It's made from inorganic and organic. And you can do, I'm just gonna skip over this, it's not important for my talk today. But this is another MOF. You can see it rotating. And the way I would describe it is that if you were to, a MOF looks like baby powder. If you were to zoom in on one granule, take that grain of powder and zoom in all the way to the molecular level, you will find that it's drilled with holes, billions and billions of holes in one granule. So when you drill those holes, you increase its surface area. So in fact, in 1 gram encompasses space equivalent to a whole football field. The gram is like a small cube of sugar, okay? That's mind-boggling, but that was our discovery. And it was done by Halian and me at Arizona State University. Okay, in fact, the porosity was so high that my colleagues in industry thought that it was a misprint in our paper. Okay, so it was not a misprint, it was real. Okay, so this is just an illustration of what a MOF is. We're going to zoom in on the granule as I described to show you how we can control matter on the atomic and molecular level, and we can stitch things together, just like building Legos, okay? You can see now that the framework is full of holes into which you can compact gases, store gases like hydrogen, water, CO2. And there, we developed these materials to have hydrogen cars that run on natural gas, and I'll show one result on how we can capture carbon dioxide from air and how we can generate water from air to water. Okay, you all know that our planet is experiencing heating trend, and in California and many parts of the world, the fires are becoming more and more intense, okay? And the cause of this is carbon dioxide emission. A baby born today is breathing double the amount of carbon dioxide compared to a baby born before the Industrial Revolution, okay? So it's altering our planet, it's affecting our lives, it's affecting our livelihood. Okay, so this is the material that we invented. It has pores, and we decorate the pores with agents that can seek CO2 and trap it, okay? And this is the uptake. You see the material is taking up CO2, and the more water you have, the more CO2 it takes, because water facilitates the uptake of CO2. The chemistry in the pore allows you to have water and CO2 at the same time. What I want to say here, I don't want to be too technical, but what I want to say here, this is the best material in the world for capturing CO2 from air, because it can be cycled and it can capture lots of CO2 because of the high porosity. So what I am saying is that now you can see that my journey of beauty and super, not so intellectual beginning can lead to really magnificent developments. The second problem that I want to talk about is water. By the year 2040, almost a quarter of humanity would be experiencing a water crisis, not just water stress, but a crisis, okay, where people will not have enough water to drink, and including in Taiwan, that droughts in Taiwan will become more and more severe. You can see here, Taiwan will have a water crisis. So, can we create a new source of water? The answer is yes. There's so much water in the air at any one time. There's almost 13,000 cubic kilometers of water in the air at any one time. That's as much water, more than we have actually in rivers on our planet. If I was to give each person in the world 50 liters of water a day, I would have only used less than 0.01% of the water in the air. So there's a lot of water in the air. And can we design a MOF that can trap this water and so that we can create drinking water? Okay, here's the MOF, okay, and I'm gonna slice the MOF, one pore of the MOF, and show you how it assembles water from the air inside it. So it concentrates the water into the pores, and then when the pores are filled with water, you heat up the MOF, the powder, and it liberates the water. You can collect it and condense it and drink it. Okay, so here it is. Oops, sorry. Ah. Okay. That's the pour. We're going to slice it so that you can see the interior. Now the first water goes in, second water, third water, fourth water, and then you start filling up more and more of the pores. You probably learned about hydrogen bonding between water molecules, and now water is being assembled and stuffed into the pore, filling the pores, and that's how, so the MOF is an agent specially designed to trap water from the air. The first water molecule goes in and attracts the next one, and the next one, and the next one, in a cooperative fashion. Okay, so we didn't stop here. We wanted to show that this works actually in real life. And so we designed a machine. It doesn't look very attractive because there's a lot of wires, because it's a prototype. And this machine has 200 grams of MOF. A door opens, air goes in, the water from the air goes into the MOF. When the MOF is filled with water, you heat it up and it collects the water. You can see water puddles at the bottom here. This is a water puddle from the 200 grams of MOF, okay? And now you are collecting 5 liters of water, okay? So 200 grams generate 5 liters of water in your kitchen, and the device will not be bigger than a microwave oven. Your own water, you control that water. You can add minerals to it and make it tasty. You can make it carbonated. You can make it sweet. You can have one in your room. You can have one in your parents' room, and so on. This is a personalized water. And you have your water independent of everyone, right? This is water independence. Every person in the world has the right to access water. And this allows you to have your own water independent of the city without getting it from the city. That is what I'm talking about. So this student surprised me by drinking the water.
Cheers. Nice.
No. It's the cleanest water you ever make. We tested it, no metals, no organics, nothing. That's why he drank it. It doesn't taste very good because it's distilled. Okay, to make it drinkable like the water you have in your kitchen, we have to add a little bit of minerals, which is something that is done for drinking water. But it could be used for drinking, could be used for agriculture. Now, I'm going to show you another device that collects even more. This, I call it the rain in a box, okay? This one has fans that push air into the MOF, and then now you're going to see droplets coming out, okay? So we're scaling this up. Now we can collect even more water. Do you see the rain? Okay, rain in the box. And this is turning air into water. Okay, a little bit low tech, but it works. It works, okay? We can give it to the Taiwanese manufacturers and they will make it very beautiful and they produce it in hundreds of thousands of units, right? That's my dream. We are working on that. Okay, we can take even a smaller device just to show that it works in the driest deserts in the world, in Death Valley in California, the lowest point in the United States, and the driest. And you can see here that we can take water out of the air with no energy input aside from just ambient sunlight. Okay, so now we have designed something as large as a small refrigerator that delivers 22 liters per day. So this is where we are today. Without energy from electricity, just sitting in the desert, 1 ton of MOF will give you 2,250 liters of water a day, every day for 7 years. If it's electrified, it's at 25,000 liters of water per day, every day. Recently, we doubled these numbers because we made a MOF that can double the uptake, okay? But even at these numbers, it's very, very, very exciting. This is real, okay? This is going to help everyone in the world, not just in the desert region, but in the humidified region where there may be drought or the water is not clean. You can use these devices. Okay, my last slide here, the one before last, the last technical slide, is that we are now using LLMs. So my story has taken how many years? I came to America when I was 15. Now I'm almost 60. It took a long time. It doesn't need to take that long. We have LLMs, we have generative AI, and we can speed this up. So we are working with LLMs to text mine, to do it much faster than humans can and more accurately. Image mine, simply by using conversational language. No coding is required. In fact, the LLM do all the coding for us. Supervisor, the students have designed LLMs that replace me in the lab, where they go to the LLM for supervision to learn how to do experiments. And research group, a MOF or a COF that would have taken us 3 years to make, we can make in 2 weeks, from 3 years to 2 weeks, just using standard LLMs. Okay, so what I want to say here is that in our research, we have always pushed the frontiers. And the next frontier is AI. It's going to simplify and make rapid discoveries and scale them so that they are available to everyone in the world, accessible through platforms that employ this chemistry. So what did I learn that I would like to communicate with you? I learned a lot, but let's boil them down to just few. Never believe those who say it will not work. Whenever someone tells you it's not going to work, it is a guarantee that it will work. Now, why do I say that? Because nature is so rich, and we have only studied a tiny fraction of what nature offers. So whenever somebody said it's not going to work, I knew that it will work. I guarantee you that. And when somebody says it doesn't work, tell them because you didn't make it work. Okay? Not because it doesn't work, it's because you didn't make it work. You didn't work hard enough to make it work. You didn't think carefully about it to make it work. Because you keep saying it doesn't work, you don't want to do the experiment. Okay? So this is, I'm preparing you for the future. You are never alone. When you make new discoveries and you're moving your field in new directions, you will have many people who are trying to push you down because they're very jealous. That's our world. Very competitive, very jealous. I'm being truthful here. And the higher you go, the more enemies you have. Don't be discouraged. You are not alone. There is something that I call the 5% rule. The 5% rule, when you think the whole world is against you, the whole world doesn't believe in your invention, there is 5%, at least 5% of people out there who believe in you and understand on a fundamental level that what you're doing is great. And that's enough. The 5% is a 100% certainty. Okay? These people exist everywhere. And remarkable things often come from unremarkable beginnings. So I never use excuses, say, oh, I came from a poor background, we didn't have blah, 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 blah. I don't look back. I look ahead to the opportunities and develop things. So remarkable things often come from just humble starts. Okay, well, I work with brilliant students, and I love working with them, okay? Maybe some of you one day will join my group. I would welcome you to join my group for PhD, okay? And you will experience the thrill of scientific discovery. And if you're fortunate, you can change the world. Okay, so thank you very much for inviting me. It's a pleasure to be here. Yeah.
Thank you, Dr. Yaghi. That was an awe-inspiring speech. We definitely believe students are all inspired by your lecture. Please have a seat.
Next is the session of When the Youth Meets the Master. There will be 4 11th graders from the audience to join the talk as the panelists. They are Peng Yuxiang, Xie Yazhen, Cai Jun'an, Wong Xuanbo from National Hsinchu Senior High School and National Hsinchu Girls Senior High School.
Also, let's welcome the moderator of our symposium, Ran Tingwei. Panelists and moderator, please proceed to the stage and be seated. We'll start the session in just a moment.
Good morning, Professor Yaghi, distinguished guests here today. Thank you all for attending this meaningful symposium. I'm Tingwei Ran, the English teacher from National Hsinchu Senior High School. From Professor's speech and then the research conducted in the lab, we're extremely thrilled. For Professor has transformed what has been seemed impossible into reality. For example, with the research, finding an oasis in the desert is no longer building castles in the air. It's not chasing the distant, chasing the castles in the distant mirage. Indeed, Professor Yaghi is making water resources accessible to everyone. Now, we'll begin the symposium. And if you have any questions, feel free to scan the QR code on the screen and type in your questions. And if you have any ideas that you want to consult Professor Yaghi, then we will do it in this part. So, good morning. Okay. Thank you for attending this symposium. Lots of students are curious about several questions, including the motivation and also some of the important figures that may influence during on the journey of your life. And also there may be some challenges that you encounter that the students are curious to know how you cope with these difficulties and challenges. And also the students are also want to know that what will be the advice for the generation to come. So for the first question, so Angus, would you like to propose the first question?
Good morning, Professor Yaghi. And I'm Angus, and I'm from National Senior High School. So first of all, thank you for your excellent speech. And it is my pleasure to have this opportunity to sit here and speak with you in person. So as we know that you were born in Jordan to a refugee family, and this unique experience must have shaped your worldview. So I am curious that how did your childhood and early experiences influence your path to chemistry? And what advice would you like to offer to young people who are facing similar circumstances?
Very good question. Thank you. Thank you for the question. I think that for me, as I mentioned in my lecture, I was kind of a lost child. I wasn't sure what I am doing in this world, quite honestly. It was a strange feeling. I spent, it seems like my whole childhood watching other people and watching the world pass in front of me. And I was sort of in a different world because I am thinking about our let's say, humble situation. I think that when I saw those molecules, I realized that there's a whole world out there that perhaps I can use as an escape, like a holiday from the difficulties of the childhood. And so that kept me very interested, that kept me pursue that, try to learn more, and so on and so forth. And that was revolutionary in my life, right? It transformed my life. What I really want to say to all of you, and thank you for this great question, is that some of you may not know what you're interested in, okay? Or you may be interested in a lot of different things, okay? My advice is that to just pick something. Just look at all these things that you like and pick the one that is drawing itself to you the most, okay? Just pick something, anything, for God's sake, anything. And once you do that, and you start digging deeper and deeper and deeper into that object, you will become interested in that topic. Now, don't worry about the other topics you're interested in, because once you're proficient in one, you become intelligent enough to be proficient in others. For example, I was a chemist. I was trained as an inorganic chemist. I became a solid-state chemist. I became a chemical engineer. And now I am learning computer science and how to use AI. So the deeper learning allows your mind to be adept to evolving into different directions. And so you don't have to worry about yourself being interested in many things. At some point in your life, you will be able to do those things, okay? But it's absolutely essential that you pick something of interest, and that will put your life on a very sound track. Yeah.
Thank you, Professor. I think just like what professors mentioned, that doing research is like standing on the shoulders of the giants. And sometimes you may not know what you're going to do at the current state, but probably you can look for some information online and to see what people are currently doing right now, and probably that may spark your curiosity in any fields. Just like what professors mentioned, pick anything that you like, and research science always starts with questions and doubts. Yes. So one of the students is also curious about how the early experiences, especially shaping the work and research that professor is currently conducting. So Ocean.
Good morning, Professor Yaghi. It's an honor to be here with you. Your research is widely recognized for addressing critical issues like water scarcity. Given that you grew up in a water-limited region, we're curious to learn how those early experiences influenced your scientific focus on this water shortage problem. Could you share how your background shaped your determination to find solutions? Thank you.
Okay, that's another very good question. In fact, I can tell you a secret. I wasn't interested in solving the world's problems. I was not interested in that at all. And my childhood with little water or water at dawn had absolutely no impact on me choosing chemistry. It absolutely is. I didn't choose chemistry to solve any societal problem. And that was true throughout my career until we discovered MOFs. What I'm trying to say is that I was in it for fun. I was having fun. Somebody's paying my salary. Okay, I teach students. I was having fun. Fun to do research. I had lab. I can do whatever I want. So it's not always necessary to have a blueprint, okay, in life, to have a logical derivation of your career. You should let yourself take risk, okay? Do things that are not like everybody else. Deviate from what others are doing. Plot your own path. But I didn't ask this big question, how do I help society? That was not on my mind. What was on my mind, how can I make enough money so that I can send back to my family the money that I borrowed from them? Okay, that was on my mind. But what was more on my mind is that I was in love with molecules and I wanted to work with molecules. But once we make that discovery, then you have an obligation to society to take that discovery to benefit society. Because remember, society paid for that research. So it was our obligation as scientists to take that discovery. And so when we discovered moths, we discovered they have high surface area. We immediately started thinking, well, okay, how do I make a difference in the world? How could these be deployed in society? What problems could they solve? And I think that that's, so my point is that when you start, you don't know where you're gonna end up. So you have to just go with the flow, but try to do your best and be very observant and open-minded about where research is taking you. I hope I answered your question. Thank you.
Thank you, Professor. I think that I'm not currently studying for my doctoral degree, and my professor always says that you have to do something that nobody else has ever done before, and don't be afraid of making any mistakes, and don't be afraid of being a stranger in this kind of field, because once you step out of your comfort zone, then probably you will discover, wow, this is a whole new world. Okay, so one of the students is also curious to know that based on the current research that Professor is now conducting, that the future of MOF-based technologies. So Ryan, yeah?
Good morning, Professor. I'm Ryan from National Shinju Senior High School. And your work on metal organic frameworks have captured our imagination, especially in the water collection devices. And to my curiosity, how soon do you think these devices can be deployed widely, and what are the key points to that them be accessible for everyone?
Again, very, very nice question, a complex question. So just to give you the answer right away, there are now MOFs that are commercialized for capturing CO2 from cement plants. Cement plants burn a lot of fuel because you have to heat the cement to high temperature to make it robust. This is commercialized in Canada, and already the MOFs are trapping CO2 from these cement plants before it reaches the atmosphere. So already this is happening. So it means that it's economical enough to be deployed commercially. In terms of water harvesting is complex because nobody has done it before. So we have to really invent not just the materials, but also how these materials could be configured in a device for maximum energy efficiency and maximum water delivery. So that has taken us some time, but now, so we started on this in 2014, and now we're almost ready, as you can see from my presentation. We have devices that work, and their performance is with energy efficiency and decent water delivery. And so we are within, I would say, a year and a half of, and part of why I'm here is that I'm talking to a lot of manufacturers in Taiwan to see what would be the potential of producing these here. So I think that's, but a lot of work has been done to make these efficient and cost-effective. And now we are almost ready for manufacturing. Thank you for your question.
Thank you, Professor. We all think that the techniques is groundbreaking because it does help people around the world, and probably especially those who cannot afford clean water, just as mentioned in Sustainable Development Goals, that we aim to solve some of the crises by 2030, right? And one of the students is also curious to know that some of the early experiences, how they influence the life. So Janet, yeah.
Good morning, Professor. I'm Janet from National Hsinchu Girls Senior High School. And moving to a new country as a teenager can be challenging. So when you moved to the United States, how did you adapt to a new environment, and what strategies help you overcome the difficulties you faced?
Another really good question. I have no idea. I have no idea. I think you know, it's like in the old-fashioned battles. Your general commands you to go forward, and there is no option to go backwards. And in fact, this is how I felt. I felt I have to go forward. Okay, do well in school, try to earn some money to survive, this kind of thing. Aim for going to better university, you know, all these things. I never really, failure was not an option, and retreating was not an option, and definitely when my reaction didn't work the way I wanted in graduate school, I was thinking, oh my God, I'm gonna fail and then go back to Jordan in defeat. You can imagine that there's a huge motivating force for me to stay overnight to work on my problem and make sure that I succeed. So failure was not an option, and retreat was not an option, and it shouldn't be an option. If you are all privileged to be in this great school, okay? Many people in the world do not have the opportunity to be in a great school like this. And I am privileged to be at the top university in the world, in a top chemistry department, #1 chemistry department in the world. It's really our duty as citizens of the world to not retreat, okay? The failure is not an option. Retreat is not an option. It's our duty. If we, the privileged, cannot solve the world's problem, who will? So you keep that in mind. So that gives you an idea where I was. Yeah. Yep.
Thank you, Professor. Following that question, I myself also curious about whether or not, Professor, when you went to the States, have you ever suffered from nostalgia, that at the time that you miss your family and then the friends or something, and how do you deal with these kind of emotions? Yeah.
Very good question. Yeah, I missed my family, but I also liked the new culture. I like the freedom of the new culture, and I like the fact that I can do whatever I want. So I think that, but I did miss my family. I was calling them often and writing letters to them, and I got a hint from my father at some point that instead of writing these letters, you might be better off doing your homework. So I think this tells you the mentality of the time. But in general, I would say overall in the net, I thought it was positive because I was having freedom and exploring on my own. Yeah. But there is no doubt you miss your family. It was very tough. Yeah.
Thank you. Ryan is also curious about the details of how the applications of metal organic framework could be. So Ryan, would you elaborate on?
Greetings, Professor. MOFs have demonstrated immense potential for storing water in arid regions. And these materials also have the competence to magnify the massing storage capacity in cars. And beyond these applications, what other future possibilities do you envision for these materials, especially in addressing global challenges?
Thank you. That's another great question. I forgot to mention the answer to this in my presentation. We've invented a way of designing materials like Legos, basically. Anything you can imagine could be made. And you can also design them with great precision. You can put atoms exactly where you want them. This really has expanded the scope of chemistry. And now hundreds of thousands of new materials are being reported based on this chemistry. So the possibilities are endless. Not only are they becoming important in clean air, in clean energy, clean water, but also in biotechnology, in electronics, in many, many applications. Why? Because we know how to modify or how to design matter, how to make tailor-made materials for very specific application. So even with all the chemistry that I've discussed and all the developments over the last 30 years, we've only scratched the surface. There's so much more to be done. This is why I am very excited about the prospect of AI in exploring and exploiting this very large space.
So speaking of artificial intelligence, we all know that it is now prevalent and then ubiquitous. Everybody uses AI right now. Even I myself sometimes would rely on artificial intelligence, the chatbots, to help me do some work and tasks. So Janet is also curious about how to incorporate the techniques with the current study, right, Janet?
Greetings, Professor. You've mentioned that you have already incorporated AI into many of your studies and works. So can you talk more about how you envision the integration between your work and the AI technology?
Thank you. I see AI has a huge potential in transforming science and specifically transforming reticular chemistry. You might say, well, you made hundreds of thousands of compounds. I think that that's pretty good. Well, it's not good enough because that's only a very small number of materials compared to the very large potential. How are we going to do this? When my students or researchers take years to make a novel material or a new material, how will we explore all this in our lifetime or at the time scale that society operates, right? You consult your iPhone and within seconds you can learn about cultures far away, you can learn about science that people are doing everywhere. Society is moving at a very fast pace, and science needs to catch up, okay? In chemistry labs, my lab, before AI, we were moving at geologic times, okay? While society is moving at the speed of light. So it's our obligation to really develop tools, to engage in AI tools, engage in using LLMs, to speed up the process of discovery, and to scale. And what I mean by scale is that people around the world should be able to use chemistry. They don't have to be chemists. Like, I'm not an electrical engineer, but yet I can use my iPhone. Why shouldn't people be able to make new materials that are not chemists? We can do that with the aid of AI and building platforms that allow people to plug in and consult these platforms, get compounds, and develop startups to solve their problems in their locale, rather than having few scientists in few countries solving the world's problems. Why not have many scientists in many countries solving the problems? So I think that there's a huge potential. You will hear people say, oh, well, it doesn't give novel answers, right? We are developing generative AI models to allow us to make novel compounds that, let's say, do better in water harvesting. And people always critique, some people critique, saying that it's not giving novel answers, it's just giving you ordinary answers. And my question is, to them, is how will this technology evolve and become better if I don't engage with it, right? I am an experimentalist, we are scientists. And clearly AI is gonna play a major role in development of science. So we need to plug in and participate in order for these models to get better and better and better at solving chemistry problems, right? So again, I advocate experimentation. Do the experiment, be proactive. Yeah. Yeah.
Thank you, Professor. Always remember to have the faith, and even though now probably most of the people, they're afraid that to someday that artificial intelligence may probably control us or something, but go back to the reality, it is human beings or us that we have to try to, we can count on artificial intelligence technology to help us to make the process faster, but eventually we all need to know how to use that. Okay, so Ocean, would you like to propose the question?
Okay. Greetings, Professor. The current generation, especially people that are born from the 2000 and to now, they face a world of both challenges and opportunities. In your view, what essential skills or abilities should young people develop to navigate obstacles and realize their potentials? Thank you.
That's a very deep question. I think the challenges you will have is distinguishing facts from fake. So this is going to be a big problem. And you might be able to get away with fake and make lots of money with fake, but it doesn't make you a better person. And you will not be contributing positively to the betterment of humanity. So the responsible people among us that want to help build a better world, a more peaceful world, and better humanity, have to really figure out a way of deciphering fact from fiction or fact from fake. And so it requires a little bit more effort, because fake is a mountain of things, and facts have to sort of struggle to rise to the top from under all this fake. So how do I get to the fact? Well, you get to the fact by being smart and taking your time in consulting as many sources of information as possible, and being intelligent to say, does this make sense? And if it doesn't make sense to you, well, do more research. And very likely it may not make sense. So if you do that, this diligence, you will arrive at a place that makes you more capable than anybody else, right? So this is a way to push yourself forward in your profession. You spend a little bit more time trying to find the facts and trying to learn. We are learning how to distinguish facts from fiction. And you develop tools over time where you can do this even faster. And as you become proficient at distinguishing facts from fiction, then you get ahead. You'll be on top of your profession. So I think that that's one of the things that the younger generation have to reckon with. The other thing is that, and it is somewhat related, is that I think when you hear or see something or you read something, You need to learn how to strip the fat from the meat, okay? It's like a big sheep with big hair, and then when you shave the hair off, the sheep is small, okay? You need to distinguish what is real and what is not real. And again, that's a skill you develop as you seek it. You will develop these skills. Again, that makes you better at your profession. So it's related to the first point, but again, when you're faced with things, don't be afraid to dig down to the substance. What is the substance of this? And is there enough substance, right? So I think those two things are going to be important. They've always been important, but now they're becoming even more.
So I think what Professor is going to tell us is that we're now bombarded with all kinds of information every single day and even at every moment. So it's critical that we develop the media literacy and then try to find whether or not the source is reliable. Yes, and Angus, yeah.
Greetings, Professor. And you have long envisioned chemistry as a solution to global challenges, and your work has brought you closer to that goal. So I am curious that looking ahead, what major global issue do you plan to focus on next, and how might reticular chemistry play a role in addressing it? Thank you.
Thank you for that important question. Almost 90% of people of 30 years old or less live in the developing world. There is no peace on this planet. There's no well-being of this planet if we cannot bring these people along, okay? And I see AI, and in a small way, reticular chemistry, as a way, if we build these platforms that I'm envisioning, where anybody can plug in and learn how to do research using those LLMs that I have discussed, then perhaps we can provide opportunity for people everywhere, whether it's in research-strong countries or in developing countries or poor countries. We give them opportunity to learn and plug into research and start improving themselves, their mind, and in so doing, you are improving the quality of their life. They're improving their quality of their life. You are allowing them to have tools to do that. So I see this as really my next frontier, the next challenge, is that with AI, this idea of allowing young people to plug into research no matter where they are becomes viable and scalable with these platforms. And reticular chemistry, because it's so easy to make these compounds, the entry point is low. You don't need to know very much to make a MOF, but at least it's a magnet that brings you in to start thinking in a scientific way and start improving your life. And when you improve your life, then you're a seed of change in that environment. You're an example for others to emulate. So I want to, this is my target. This is my long-term vision. Beyond water harvesting, CO2 capture, and all of that, I want to be able, at the end of the day, to help others plug into research and enjoy what I have enjoyed in scientific discovery.
Thank you, Professor. Some of the students and audiences, they have proposed lots of questions. I see one of the questions that the students are curious to know whether or not the MOFs will contaminate the environment or after it is abandoned, and how could it be, well addressed when it comes to making it recycled.
Just like any other invention, if you're irresponsible and you don't think about the long-term effects of what you're using, it will ultimately harm the environment, harm our planet, harm the people that live on our planet. So I am very happy that more and more we as a global society are more and more concerned with with studying the lifetime of these inventions. Okay, so I think as we deploy MOFs, coughs, and other things, other compounds, we need to be conscious of what is the long-term effect of these on the environment if they indeed end up in the environment. One thing I can say is that we are very much working hard at making green synthesis of MOFs. For example, the MOF that goes into that water harvesting device, at the end of the MOF's journey, we can dissociate the metal from the linker and then reassemble it in water with zero discharge, so completely recyclable. So when we are working on problems, we always think about, okay, what's going to happen at the end of life of this device or of this material, and be conscious of trying to close the loop around it. So that's what I would say on that. But let me just say this. Part of civilization advancement is that with every technology, there will be good things and bad things. And to avoid these bad things, we need to think ahead about what could be the detrimental effects and address that before we get there. But I'm not afraid of exploration. We are not going to not use a technology that is beneficial to people because we think it's going to contaminate the world. We will use it, but make allowance or make plans for how to deal with it.
Thank you. We all know that technologies could be a double-edged sword, right? So sometimes we also have to foresee what kind of consequences it may bring about before we really dig into the process. I see some of the interesting questions. A lot of students are curious to know, would this kind of technique be very expensive? Or how soon could it be affordable by, like the citizens, or like just instead of the laboratories or governments? Yeah.
So we already have these deployed and being tested in different places around the world. And the cost, even at this initial stage, is 1 cent per liter of water, just 1 cent. 1 cent. So for a family of 4, that's 4 cents to have drinking water a day. Okay?
Yeah, I think it's thrilling news to this people sitting here. Even 4 cents could be it sounds accessible, affordable nearly to every family, or like in some poor regions, probably the government that can offer more financial support if they lack the so-called clean water resources. Yes, and also let me see that. Ocean, would you like to? The same question. Okay. So, like, okay. One of the students, he or she is curious to know that we all know that during the experiment we're bound to encounter a lot of failures, right? So, are there any specific failures or setbacks that really may probably draw you back into reality and probably I want to give up at that moment? Yeah, Professor.
Very, very, very good question. We are controlled by the way we think. Okay, we behave because of the way we think. If you think about not getting the results that you're looking for as a failure, then yes, it's a failure. But if you think that not getting the things that you are looking for in an experiment is an increment to success, is a step forward, then it's a success. It's just a small success on the way to a bigger success. When you do an experiment, you are learning. You're learning about the system. So when the system doesn't behave the way you expect, that's a dream come true for scientists. That means you might discover something really new, right? That's, to me, it's the way we think that makes a big difference, right? Because failure and success has to do with the way we think, not because there is somebody classified our world into failures and successes and they fall in those categories. It's the way we think. So when we experiment, we will not get what we're looking for, almost always. And I love it. And scientists love it, because when you get something unexpected, at best, it's a great discovery. At least you are learning about your system. So I call those, between quotes, failures as increments to success. There are no failures.
Thank you, Professor. As we all know that students in Asian countries, they're suffering from heavy academic load, and yeah, so they're curious to know that if they really want to dig into scientific research, what kind of suggestions would you offer to students like in Asian country or like in Taiwan, that when the student, especially senior high students, they had to face lots of quizzes and then lots of assignments every single day? And what practical suggestions would Professor offer to these young kids?
Yeah, I think you're loaded with activities, with studies, with homework, and you feel during the term that you have no time to do anything. My suggestion would be that if you have a break, whether it's a Christmas break or summer break, you might want to shadow somebody in a research lab. If you're really at all interested in research, you might want to just get a job, okay? And explore the world beyond the school. You could learn about research, or you could learn about how to communicate with people in a shop. Okay, you could maybe get an internship. I'm not sure what the laws are in Taiwan, but in the US recently, we cannot allow students below 18 years old to work in the lab. But we can have them do computer work, or they can shadow people in the lab. Okay, so I see a couple of people in the front here that I like, because they've been listening to me very intently. And I would love to have those students come to my lab and be visitors. And later, I want them to be graduate students in my lab, okay? And I have recruited students that way that have gotten PhD in my lab. So what I am saying is that when you have free time, try to, and it may not be as easy, but at least if you try, there may be opportunities to do internships, maybe be part of a program that allows you to do something outside academic setting, explore research, maybe visit TSMC and see what they are doing, you know, this kind of thing. Yeah.
Thank you, Professor. I think what Professor Yaghi wants to say is that try to explore every opportunities and possibilities, and try to seize every moment, like the spare time every section, and that could make all the differences. Yes. So since now the time is drawing near the end of the symposium, we would like to express our sincerest appreciation for being here today. And one of the things that Professor mentioned in the speech today was that if you want to go fast, then go alone. But just like what Professor showed everybody, that in the lab there are so many young and distinguished teenagers and young scholars, then probably in the future, if you're interested in this kind of research, then you can put more efforts to do it. And when you find the partners, and especially follow the path from the professors, then probably we can go far. In the near future, we can make a little bit difference. Then that would make the world even better. So I think I'm now handing the microphone back to the host today.
Once again, thank you, Dr. Omar Yaghi and panelists for giving such an impressive conversation between the youths and the master, which was so thought-provoking. Please arise from your seats as we will take a group photo.